Welcome to the fourth part of TI's Demystifying Surge Protection video series. Now that we've covered the basics of transient surges and TVS diodes, let's look at some common but costly mistakes that are made while selecting a TVS diode. The first common mistake is to ignore TVS variation over temperature. Most surge testing is done at room temperature, but real systems commonly see surge events at temperatures of 85 degrees Celsius or higher. Unfortunately, TVS diodes that can comfortably pass a surge test at room temperature offer no guarantees of passing at high temperature. Most TVS diode datasheets include a graph showing derating over temperature. TVS diode peak pulse current derates significantly at high temperature, often to half or even a quarter of the nominal value, so ensure that the TVS peak pulse current at your maximum ambient temperature will not cause failures. The second common mistake is to confuse reference waveforms when considering TVS peak pulse current and clamping voltage. As discussed in the previous video, TVS diodes always define peak pulse current and clamping voltage in reference to a specific waveform, but unfortunately TVS diodes are not always specified in reference to the IEC 61000-4-5 standard waveform. Commonly, TVS diodes are specified reference to a waveform with a 10 microsecond rise time and a 1000 microsecond half-length. As you would expect, due to the much longer length of the 1000 microsecond pulse, the peak current for this waveform will be much lower than the peak current for the IEC 61000-4-5 pulse. Because of this, the specified IPP and V-clamp are not applicable during the 20 microsecond IEC 61000-4-5 test. Datasheets often include a graph that translates the peak power versus pulse length. To avoid misinterpreting the TVS specifications, make sure that the reference waveforms in this datasheet is the same as your system test waveform. The third common mistake is to ignore the TVS diode parasitic elements. Like any circuit element, TVS diodes have leakage currents and capacitances. However, often new designers don't realize how large these parasitics can be. Leakage currents, especially for low voltage TVSs, can sometimes reach as high as a milliamp. Even worse, TVS diodes rarely specify leakage current at high temperatures. In battery-powered or power-conscious systems, this leakage could be unacceptable. TVS capacitances can be large as well, often higher than a nanofarad. While higher capacitance is acceptable in some applications, for communication lines this can attenuate the signal and destroy a required eye diagram. Before selecting a TVS diode, look at the parasitic elements and ensure they are acceptable in your system. If these three mistakes are avoided during TVS selection, it will lead to a more robust and effective surge protection stage. The limitations and concerns that have been discussed are inherent to all diode structures, so if a design needs more precise protection, it is necessary to move to a different protection topology. That's where TI's flat clamp surge protection, which will be discussed in the next video, can help solve the problem. Thank you for watching.